Hey friends, the goal of this video is just to help you figure out the definition I'm about to lay down in the next couple videos because it looks pretty weird, but it really is an old friend I just want you guys to be aware of. We're just making it look all crazy. Um, One of the goals of calculus, or one of the tools calculus provides, is a way to find the rate of change at an instant in time. If you understood what we were saying before about slope and rate of change being the same thing, that's great when things are straight lines. But if this curve represented somebody's distance over time, there'd be speeding up and speeding up and speeding up. And I can't say that they went 30 miles per hour the whole time. I could pick a specific point in time and say at that moment they were going 15 miles per hour. In fact, you guys already did stuff like that. If you did the previous activity, when you zoomed in on a specific point and found that slope, whatever that slope was, that would be the rate of change at that instant. We want to find a way to determine that slope without using a graph and without zooming in. Now, you know how to find slope. It's the change in y over the change in x. So if you had 2 points and you did y2 minus y1 over x2 minus x1, you know that's the slope of a straight line. But this is curved, and that's the problem. But is it a problem? It's not, because if I look at a small enough piece of a curve, it's going to look like a straight line. So if I get close enough to the point that I'm interested in, then I'll have a straight line and I can look at that slope. Now, where else in this class have we talked about things being close enough? Really close, arbitrarily close. Sounds a lot like a limit. So the toughest thing about this is the new notation, but the general idea, you guys can definitely handle it. If I want to be specific, I need to pick a point to talk about. I'm not telling you guys what the x and y values are. I'm just telling you guys some generic function called f of x. Well, I will say this. We're going to pick a point at x equals 10. So let's pretend like this is the point 10. I don't know the y value, but I do know what the function is. So if I plug 10 into f, I would get the y value. So if I had to label that point, I can say it's 10 comma f of 10. Now, of course, to find slope, I need 2 points. So I need a second point that's not on that point. And really what I need is that second point to be super duper close to this point, because I need a small piece of curve if it's going to look like a straight line. So how am I going to notate this new point? Well, the idea is I was at this point 10, and this point is even further down the x-axis. I'm going to say that it's h away. So from this x value to whatever this guy's x value is, I'm going to call that h. That means that if from here to here is 10, and this is h more, then from here to here is 10 plus h. And if I wanted the y value of that point, I'd take that 10 plus h and I'd plug it into f. So if I were going to label this point, I would call this point 10 plus h comma f of 10 plus h. This is the x value. This is the y value that I get when I plug 10 plus h into f. Now, what we need to have happen is we need to look at a very small piece of this curve. If I want to know what the slope is at this point, I will do this y value minus this y value over this x value minus this x value. And I want this distance between the x values to go to 0. I can actually go on 0. You'll see why when I do the notes. But if I let it get closer and closer and closer to 0, that point on the right gets closer to the point I'm interested in. And the path that connects them is more and more and more like a straight line. That's pretty curvy, not so great. As I zoom in, it's more or less a straight line. So as you look at the definition of the notes, the definition of derivative, the rate of change at that point, you're going to see that it is basically change in y over change in x with h going to 0. I do want to say, too, there's nothing special about the point 10. I could have called this guy x sub 0 and f of x sub 0, and then this would have been, oh, I can't do that. Oh, dear. Well, I could have called x sub 0 and f x sub 0, which is what you're going to see me do in the actual notes themselves. So I hope this is going to help you figure out what the definition does, and bear with me, man. You guys are doing great.